My name is Staci Jett.
My name is Jennifer Gregory.
My name is Josh Elberfeld.
And we are seniors at Rancocas Valley Regional High School.
Today we'd like to present to you our AP Statistics Independent Research Experiment titled
The Purity of Filtered and Unfiltered Water at Rancocas Valley and Students' Ability to Differentiate Between the Two based on grade level.
You're a student walking down the beautiful halls of RV and you become quite thirsty. You look to your left and your right and you see two water fountains that vary greatly in appearance. But which one will you choose? One of the old original RV water fountains or the new filtered water fountains installed last year that claim to produce a cleaner, pure drinking water for the student body? We ask ourselves, is there a difference between the water that comes from the old and the new water fountains? And can students really tell a difference? And is a student's ability to detect a difference between the water produced from the old and new water fountains of RV associated with their grade level? For instance, are upperclassmen more likely than underclassmen to recognize the difference, if present, in the purity of water from the old water fountains and the new filtered water fountains? The results of this experiment can allow people to generate an informed opinion on whether the purchase of these new water fountains was a worthwhile investment, as well as affect students' former perceptions of the two fountains. A student might even change his or her mind on what fountain they can trust to drink from every day based on the results of our experiment. Ultimately, this experiment will test the association between a student's grade level and their ability to detect a difference in the water purity of the water from RV's old and new filtered water fountains. The first step in our experiment was to test the purity of the water from both a new and old RV water fountain and determine if the new fountains actually supply the student body with a cleaner, pure drinking water. Due to monetary and scientific equipment limitations, we found the best available method for us to test the water purity was by testing the pH of each water sample. We did this by first taking a 1-cup sample of water from an old D-Wing RV water fountain and labeling it not pure. We then took a 1-cup sample of water from a new Elka filtered water fountain and labeled it pure. We then brought these 2-cup water samples to the RV Science Department and used a Hydrion pH test strip kit to find the purity, or pH result, of each water sample. We found that the water produced from the old water fountain had a slightly acidic, aka less pure, pH reading of 6. The water produced from the new filtered water fountains yielded a neutral, perfectly pure pH reading of 7. Don't be alarmed though, both are totally acceptable and safe drinking sources.
We next had to collect a random sample for this experiment. We started by randomly selecting a homeroom from each grade level. We did this by using the official RV homeroom list of the 2016 to 2017 school year shown in Figure 1, homeroom list. We numbered each homeroom on the list, starting at 01 and ending at 91. We then used the random number generator in our calculator to choose numbers that corresponded to homerooms, throwing out any repetitive numbers until we had chosen one homeroom from each grade level. Next, after contacting each respective homeroom teacher, we visited each homeroom and every present student in the homeroom became a participant in our experiment. All students were subjects of the experimental treatment, as there was no control group. A new sample from each water sample was retrieved each day of the experiment to ensure consistent quality of the water source. When we visited each homeroom, we gave every present student in the homeroom a cup of water labeled A and a cup of water labeled B. In cup A was a sample of water from the new filtered water fountains, while in cup B was a sample of water from the old water fountains. Next, we distributed a survey, shown in Figure 2, Homeroom Survey, that informed the student of what the experiment was about, asked the students to taste the water, asked the student to identify his or her grade level, and asked the student to make a blind decision on which water sample they thought came from the new filtered fountain. We then used the responses of each homeroom to construct graphs, tables, and a significance test that would test for an association between grade level and ability to detect a difference in the water purity of the water from RV's old and new filtered water fountains.
The results of our experiment are clearly shown in Table 1, Selected Homeroom Responses. In the table, the term correct responses can be defined by the number of students who selected the water from the new RV water fountains that was tested to have a pH of 7 as tasting more purified. The term incorrect responses can be defined by the number of students who selected the water from the old RV water fountains that was tested to have a pH of 6 as tasting more purified.
Now that we have our data, it's time to analyze it. We chose to use a chi-square test of independence because the two variables we were measuring are categorical: grade level and ability to detect a difference in the purity of the water from RV's old water fountains and the new water fountains. With a chi-square statistic of 9.2 and a p-value of 0.0267, as Ms. Westlake taught us, if the p-value is low, the HO must go. Therefore, we will reject HO in favor of HA, which means that there is an association between grade level and the ability of students to correctly identify the water source. From the data, we noticed that the freshmen yielded 11 correct responses and 15 incorrect responses. The sophomores had 9 correct responses and 10 incorrect responses, meaning both the freshmen and sophomores both had more incorrect responses than correct. The juniors had 11 correct and 7 incorrect responses, and the seniors had 14 correct responses and 2 incorrect. And both the junior and seniors had more correct responses than incorrect. Due to the statistical data, we proved that the upperclassmen had more of an ability to differentiate between the two water samples.
So, in conclusion, after testing the pH levels of the two different types of water fountains at RV, collecting random samples from the different homerooms in RV, and then taking the data from the samples and performing a chi-square test of independence, we rejected the HO in favor of HA, meaning we have convincing evidence that there is indeed an association between grade level and the ability to detect the difference in purity in the two fountains. Our data showed that older RV students were more likely to be able to determine which sample was produced from the new LK Easy H2O fountains. So RV, did the results of our experiment make you question where you'll get your water next time you're thirsty?